Hi, so my name is Sunil Venugopal, and today I'm going to talk through the project assignment we have for machine learning foundations for product managers on Coursera. This is the final project assignment we have that will be peer reviewed. So here is a little background on the project itself. So in this project, we've been asked to build a model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, heat recovery steam generators to generate power. We have been given a data set in a CSV format, which is a set of around 6,568 hourly average ambient readings from generators at the power plant, which we'll be using for our model. Talking about the data sets, the different columns or values that we have or variables we have in this is temperature, ambient pressure, relative humidity, exhaust vacuum. These are the input features, and as the output, we have the net hourly electrical energy output itself. So as I was saying, I have already downloaded the data set, which was provided in a CSV format. Now, looking at this is the complete list of data sets we have. And I'm going to quickly walk through the approach itself that I've taken for this project. So the type of modeling approach we have taken is the multiple regression analysis. I considered two different models for this to review the project. The first one is using all the input features that you see here, which is the temperature, exhaust vacuum, ambient pressure, relative humidity. And for the model 2, I limited it to two different inputs, which is that first two, which is temperature and the exhaust vacuum. From the data set point of view, I've taken a 70-15-15 split, which means 70% of this data from the data set that you see on the screen I've used for training, 15% for validation, and the rest 15% for testing. And for validating the model, I'm considering two different values, the first one being the R-square or the MSE, and the second one being the residual difference, which is the accuracy. And since we were given a couple of different options that we can use to build a model, I am using the approach, or the model I'm using is the option I'm using is the Microsoft Excel one. So moving right into model 1, as you see, we're using all the different input models here. We've broken down the data into the three different groups, which is training, validation, and testing. And as you see here, the resultant R-square value for this is 0.93, which is really good. And you can also see the accuracy right on top, the accuracy range here. And this was done using the data analysis option right within Excel. And moving on to the model 2, as you can see here, we're using the temperature and the exhaust vacuum here, and the same approach, 70-15-15. And as you see here, the R-square value is 0.91, which is again good. And if you see here the accuracy range, it's a little on the more wider range as compared to model 1. So based on the two different approaches we have taken, or two different models we have, the conclusion or the recommendation is to go with the model which has a higher R-square value, in this case, which is model 1, even though it's a slightly better one. But when we look at R-square and the accuracy range, both of them is better with model 1. So again, the conclusion is to go with model 1 for this. And so yeah, that's my finding. That's my project's assignment. Thank you for your time, and appreciate you listening in. Thank you.